RTMaps 让你的机器人系统从 Perception 感知开始就赢在起跑点。以自驾车系统的组成为例，刚开始的非同步系统，因为不同感测器的取样频率、取样大小、传输协定等不同因素，数据应该都是时间不同步，因此 Perception 感知时，数据需要经过及时的处理及融合，让其同步后，方能后续给同步系统经演算法或模型分析，做出运动控制的决策。这也是 RTMaps Real-Time Multi-Sensor Application 的含义。RTMaps 不只做时间同步、资料融合，它也是 End-to-End 软体整合解决方案。机器人系统从开始数据的来源，包含实体数据加虚拟模拟的数据，之后对这些非同步数据做即时处理，再经过 AI 赋能的演算法的判断推理。演算法呢支持 ROS、C++、Python、MATLAB、Simulink， 最后还可以部署到边缘运算或 IoT 平台上。RTMaps 是 DSpace 旗下的 Intempora 公司研发。DSpace 是全球在工程模拟及验证领域解决方案的技术领导者。他们提供了这一系列的 YouTube 课程，让你可以初步认识 RTMaps 软体的强大功能。昊青公司是 DSpace 台湾代理商，如你有产品或专案的需求，欢迎与昊青联络。你也可以索取 RTMaps 试用版，对于学生则有提供1年的免费试用。
Each component can have inputs, outputs, properties and actions. Click on an input pin to select its properties. The input name cannot be changed. It is compiled with the component. The subsampling downsamples the input directly. When putting 2, you will get only 1 sample out of 2. In the Type Filter tab, you can see all compatible data types that this input can accept. You can also select multiple inputs at the same time. Different property values across the selected inputs are highlighted in red. It's a very useful feature when inspecting diagrams. Click on an output pin to select its properties. Subsampling works exactly the same as for the inputs. It divides the output frequency by this factor. FIFO size is the size of the output circular buffer in number of samples. This can be changed here. In the Type tab, you can see the data type that is emitted with this output, as well as additional flags description. Let's have a brief look at the bypass component. If we look at the input types that the bypass accepts, we see all RTMaps types. Same for the output types. Now let's look at the properties. Properties can hold different types: checkbox, drop-down menu, text entry, time, integer or float. Port is here a text entry. Baud rate is an enum, which translates to a drop-down menu. Same for stop bits. Minimum exposes an integer value. Use request to send is a boolean, which translates into a checkbox. Time is also a special subtype that has its own display. Now let's have a look at actions. Actions are triggered via a right-click on the component. Here we can scan for COM ports on Windows. Help is also available for every component as an action. In the help, you will find details about inputs, outputs, properties and actions, as well as a general description. Let's load the GPS package to finish our diagram. To connect components, use the connection mode. Use the mouse middle click to set and unset this mode. Add a devectorizer component to extract the longitude and latitude from the LLA position output. The vector size property should be set to 3 if we want to get the elevation as well. Let's add a data viewer to read and set its number of inputs to 3. Now, we will perform a cluster connection. This will connect all compatible inputs and outputs together. Select the first component, press and hold the Alt key on your keyboard, and then click on the second component. And that's done.